Okay, here are the explanations if you need them. Remember, you can always just go see your teacher and ask them personally. You should have tried to go back and corrected your mistake on your own. If you haven't done that, I would pause, try that again on your own, or just simply ask your teacher. Probably everyone's done with their quizzes now, and you can get more one-on-one help. But if you didn't have time and you're at home and you're stuck, then you can watch this video and find out. So we were given the measure of angle AB, which is 105, and we know that AC is a diameter. So immediately when I know AC is a diameter, I know this is a semicircle. So I knew that AC, arc AC, is 180 degrees. I also know that this is a semicircle, so arc ABC is 180 degrees. So if this is 105, I know this little part here must be 75. Okay, then I see I have a tangent, so I use the outer angle theorem. So I have the large arc, which is ACB, that's 180 plus 75, which is how I got the 255 right here. It's half 255 degrees minus 105, that gives me 150, and then I take half of that, which is 75 degrees. Number 3, I have secant, so I'm using the outer angle theorem. Again, it's just 1/2 larger angle minus smaller angle. So the larger angle is unknown. We have the smaller angle. We know what this angle is up here. So it's 10 degrees equals 1/2 larger angle minus smaller angle. I multiply by 2 first to get 20 over here. Then I add my 20 to get 40 degrees. Number 4 is the chord theorem. Everything's on the inside. I have a chord. They gave you the angle inside this time. So remember, outline the chords first and then connect the intersected arcs. So we should have the sum of, half the sum of these two arcs, RS and TU. Well, TU was given, we're trying to find RS. So 85 degrees equals half 105 plus RS. You first multiply by 2, 85 doubled is 170, then I subtract my 105, so I know that 65 degrees is the measure of RS. Okay, moving on to number 5. On the outside, you have an intersection point on the outside of the circle. So these are tangent, so it's the outer angle theorem. If I know this arc was 110 degrees, then I know all the way around the circle is 360. So I do 360 minus 110 to get 250 degrees right here. Then I simply do that the measure of angle S is half the difference between those arcs. So it's 250 minus 110, which is 140 degrees. Take half of that, that's how I got my 70. Now this last one is a little bit messy and this is going to be difficult to explain perhaps. I started with information looking at this diagram. I started with stuff I could concretely just peg right away. One of them was the fact that this is a tangent and this was a radius or a diameter, so I knew that this was 90 degrees. So I immediately said, well, angle 7 is 90 degrees. And then I put in information I knew, which was this is 30 degrees, this is 25 degrees, and that if this is a diameter, whenever you see the word diameter, you really have to think in terms of semicircles, right? You have a 180 degrees on this side, 180 degrees on this side. That helped me fill in all these little blanks right here. So this is 125 degrees because it's 180 minus 125, or minus 55. This is 30, this is 25. So if this whole thing is 55, then 180 minus 55 is 125. So I knew this arc measure was 125. I then know if this is 100 degrees, which was given to me up above, right? It was given to me up here. Then I can find this because it's a semicircle. So I knew this was 80 degrees. So immediately, if I know this is 80, I know the measure of angle 1 because that's a central angle right there. So angle 1 is 80 degrees. Angle 2 is also a central angle, matching up with its corresponding arc, which is 100 degrees. So I know measure of angle 2 is 100 degrees. Angle 3 was tricky. It was all based on this inscribed angle, right? Inscribed angle to 30 and 25. So 30 plus 25 is 55, so it's half of that measure, which is why I have a decimal point here. Half of 55 is 27.5 degrees. Then I look at measure of angle 4. Okay, measure of angle 4 was inside. I have it inside the circle, which means it's going to have something to do with the chords because it's not having anything to do with the center. So I have this chord here, I have this chord here. So remember, we look at the arcs that were broken up by the chords. So here's an arc, So I've got to add 125 plus 30, which is 155 degrees. I think that got lost there, 155 degrees. And then I have 80 degrees right here. So I take half the sum of 155 plus 80. Well, 155, why is it 155? Because it's 125 plus 30. So 155 plus 80 is 235, I believe. I hope anyway. And then I get half of that, which was, again, a decimal, so 117.5. Okay, well, if angle 4 is 117.5, how do I get angle 5? It's supplement, right? Because those are side by side, those are supplementary angles. And because they're making a straight line right here. And then I had my measure of angle 6, which was the final one, I think. Oh no, here this measure of angle 8, this is also a 90-degree angle, so I could have done that one once I found angle 3 here. It's complementary, so this is 90 minus 27.5. Sorry, going back to the measure of angle 6, my final one, well that there was a secant, right, and a secant, secant, secant. So look at those arcs that these two yellow secants are breaking up. It's breaking up this arc, which was 100 degrees, and this arc, which is 30 degrees. So in order to get my angle 6, that's why I have 100 minus 30. We take half that. Half of 70 is 35 degrees. So I know it gets complicated in there, but you really need to trace things, get out your colors, try to see central angles, inscribed angles, these new theorems we just learned. When they're all mixed up in the same problem, I know that's when it gets tricky, but those are the ones you need to practice. Okay, get started on your homework. Come in during lunches and see us if you have questions. We're all willing to help. We all want to make sure you understand it. Good luck. See you soon.